Hi, this is a presentation of the RF amplifier working in a DRM system. In this video I want to show you a bit the characteristics that must have an RF amplifier to work with a digital signal. Here we have an exciter, DRM exciter. This can work as FM or HD, iBook or DRM. It has a board that is specifically make this work to take the transport stream digital inside and convert it in RF, iBook. To do that, we put the output of this exciter to the input of the amplifier. The amplifier takes this input and is a digital signal. It's not an FM. In this case, a digital signal has a high energy. Moreover, it has a big peaks level of power. So the amplifier is to work with this kind of system must have these characteristics: the capability to work in a linear way, in a linear class, plus the capability to have a big range on which it can handle high peaks of power and also very low level powers, because the iBook signal is modulated in AM and in phase each carrier. Moreover, it has multiple carriers. What is the point? And sometimes it can happen that each carrier has the maximum value or one of the maximum value in the same time. They are added between them and then can create a very high peaks of power. So the relation between the maximum power and the medium power here and on the iBook is very high. For this reason, we are using a 1.2 kilowatt amplifier to get about around 300 watt iBook. To do that, in any case, the amplifier must be linearized, and this amplifier has the option to work in FM in class C or work in class digital. For this reason, is are called this one is called cell 1.200 HD, because are the possibility to make a commutation for digital and to be working in linear class. But most than working linear class, they need to be to receive a signal and can be pre-corrected by the exciter, because even the most linear amplifier present on the market are not able to create a signal so linear amplification to keep the intermodulation products at a good level. So the output of this amplifier is sending to the input of the exciter, then will create the pre-correction to feed the amplifier with the right signal. The last point to speak about it, and to work in iBook, in this case in DRM, not only the linearity is important, but even it's important the robustness of the amplifier, because the high peaks of power that it receives in DRM, plus the total energy that is handling the DRM signal, that is bigger than the energy present on an FM signal. So the amplifier can be more hot, so must be able to work in this condition, and even must work with higher voltage and higher peak of voltage than are present on the DRM signal. I want to show you a little bit how is, in this case, the signal transmitter. We are taking a sample of the signal and feeding a receiver, an iBook receiver that has also the capability to give me some measurements, so parameters of the iBook signal. So I will show you now. Let me put my computer. Okay. You can see here, this is a signal we got from the amplifier. This is the demodulated signal, and you can see how all is inside the mask. Moreover, you can see the parameters, how are very inside the minimum value of signal to noise, MER, and so on. So this is a complete system. Another thing I want to show you is how on the amplifier I can go to see the pre-correction. Okay, you see here I have a menu where we can see clearly the possibility to make the nonlinear pre-correction. Of course, to do that I must do the login. So you see here I have several kinds of pre-correction, like only one time, or just the adaptative. The adaptative continuously will be checking that the intermodulation products are at the lowest values possible. Well, I hope this was interesting to you. The last things I want to tell you is that in this case, because it's what we are delivering to our customer, we are using a 1K2 amplifier, but we can use the same exciter with 2.5 amplifier, 3.5 amplifier, and 5 kilowatt amplifier. Moreover, we can grow up on the power because they are scalable. So just combining them, we can reach powers as high as, for example, typical is a 50 kilowatt FM amplifier. Then, of course, is able to produce most than 10 kilowatt DRM signal. All the amplifier is, of course, linearized, and all the amplifier must, of course, be pre-corrected by the exciter, but this is automatically. We can do that thanks to the fact that this works with a very low input signal. In this case, we are taking just 500 milliwatt to produce 300 watt in the output. So with a 50 watt amplifier, we can drive a 50 watt exciter. We can drive really very, very high power amplifiers. Well, thanks for your attention. We see you in the next video. Bye bye.